Next revision topic is gain calculation of different op-amp configurations. So here we can see that we are generally having 5 types of configuration as inverting, non-inverting, summing amplifier, differential amplifier, differentiator and integrator. So whenever we are talking about the gain is always the ratio of output upon input. If we are taking inverting amplifier, the name is inverting because if we are giving any input, suppose sine wave is given here, so the output will be showing you inverted waveform at the output side. So for inverting amplifier, we are applying supply at the negative terminal and the positive supply is grounded. So the ratio of output upon input, which is your gain, it will be given as minus R2 by R1. For non-inverting amplifier, we have to give supply at the positive terminal and the negative terminal is grounded here. So for this case, the ratio of output and input, it will be 1 plus R2 by R1. So you have to see carefully that this R1 and R2 is the same, whatever we have used in the case of inverting amplifier. The next part is your summing amplifier. So in summing amplifier, we will be having different inputs supplied at the negative terminal and the positive is again grounded. So we can use simply superposition theorem to find the effect of each source at a time. Suppose we are finding the output due to first source V1, it will be simply minus Rf by R1 because it is example of inverting amplifier times of V1, and V02 it will be again minus Rf by R2 times of V2. So the final output voltage, it will be sum of V01 plus V02, which will be equals to minus Rf, you can take common, into V1 by R1 plus V2 by R2. The third is your differentiator amplifier, which will be differentiating your input voltage. So here we are having capacitors connected with the voltage supply and the feedback resistance is R. So the output voltage V0 will be given as minus of RC. It is again inverting amplifier, that's why minus here. Then it will be differentiating your input voltage. The last case here, your integrator amplifier, it will be showing you the integrated output. So it will be again minus 1 upon RC. Here RC is known as time constant also. It will be showing you the integration of input voltage. So it is assumed that the voltage across capacitor or capacitor is discharged initially. So if capacitor is having any fixed voltage Vx across it, or it is charged with some voltage Vx, so the output will be changed as Vx minus 1 upon RC, integration of V in and dt. So in any op-amp problem, first you have to see whether it is in inverting configuration or it is in non-inverting configuration. Then we have to apply the formula based on inverting and non-inverting part. And you have to carefully differentiate between differentiator and integrator based on the position of capacitor. If we are having capacitor here in the feedback path, it is example of your integrator. And if we are having capacitor with supply source, it is indicating that it is a differentiator amplifier.